Let's take a look at the first example. I have a squared minus 9. Anytime you have one term raised to the second power and you have the difference, you're supposed to rewrite second term as a term raised to the second power. In this case, I'm going to write a squared minus 3 squared, because 3 to the second power is equal 9. Now, I'm supposed to use the formula for the difference of perfect squares. And my expression in this case is going to look like a minus 3, and I have a plus 3. You're supposed to realize that anytime we have multiplication, right, my answer also can look like a plus 3, a minus 3. It doesn't matter if you are going to multiply first the sum by the difference or difference by the sum. The answer is going to be always the same. Let's take a look at the second example. Again, I have difference and I have one of the term raised to the second power. So I'm going to convert 81 to the expression raised to the second power. In this case, I have to remember that 9 to the second power is equal 81 minus x squared. Again, I have difference of squares. I'm going to again use this formula. And my answer is going to be 9 minus x, and I have 9 plus x. And this is the solution to my problem. Let's take a look at the third example. I have squares. I have x squared and I have z squared and I have difference. Okay, so I'm supposed to try to apply the rule for the difference of squares. But you're supposed to also look at the integers 16 and 25. What we can do with them? Please realize that 4 raised to the second power is going to give me 16. So that's why I'm going to write 4 to the second power, x to the second power. 4 to the second power is equal to 16, and just x squared, minus 5 squared z squared. 5 to the second power is equal to 25. So this expression is equal to this one. Next, I'm supposed to use the properties of exponents. I can rewrite the first term as 4x to the second power minus 5z to the second power. Please realize that we got the difference of two squares. That's why I'm going to use this formula, and I'm going to write my answer as 4x minus 5z times 4x plus 5z. And this is the solution to my problem.